Picture this. A sharp engineering team spent 6 months building on a warehouse that was wrong for their workload. Every quarter the friction grows, wrong queries, wrong costs, wrong cloud, and ripping it out cost them a year. That pain is what this lesson prevents. Snowflake, Redshift, and BigQuery are all excellent cloud warehouses. But the wrong pick costs you years of friction, so we will not choose by hype, we choose by fit, architecture, cost model, cloud, and team, and you will leave with a decision matrix and a clear decision tree. Let me be honest with you upfront. All three of these platforms are mature, fast, and run serious production workloads worldwide. There is no universal best warehouse. There is only the best one for your workload, your cloud, and your team. Say that out loud. Best means best fit. So when someone tells you that one platform always wins every time, no matter what, be careful. Anyone who says one always wins is selling something. Our job today is to think clearly, not to pick a favorite. Take a look at this. One screen and every axis that actually matters. Architecture, scaling, pricing model, cloud, SQL dialect, and ops burden. Here is how you read it. Read down a column to understand a single platform. Deeply, read across a row to compare one trait across all three. This is your screenshot. One caution though, the specifics here evolve fast. Features ship, defaults change, prices move. So always confirm the current details on each vendor's docs before you commit to a decision. Let me walk you through the architecture. Because this shapes everything else, Snowflake separates storage and compute and runs across three clouds, that is AWS, Azure, and Google Cloud. Redshift is AWS native, its modern options, the RA 3 nodes and serverless, separate compute from managed storage too. BigQuery takes the most extreme path. It is fully serverless on Google Cloud. There are no clusters to manage at all. You write a query, it runs. Notice the trade, more control on one end, more hands off on the other. So how do these scale and what does each one ask of you? Snowflake gives you instant resize plus multi-cluster. You pick the size, it manages the rest. Redshift gives you resize plus concurrency scaling. More knobs, more control, but also more for you to manage. BigQuery scaling is automatic and invisible. It is the least ops and the least control. See the pattern, control and convenience sit on opposite ends. There is no free lunch, only the trade you prefer. Now pricing, and I want you to think in models, not dollar figures. Because prices change, but the shape of the model stays. Snowflake charges for compute by the second, while a warehouse runs plus storage. Redshift charges for provisioned node hours or serverless capacity in RPUs. Plus storage, BigQuery charges on demand per byte scanned or reserved capacity in slots. Read those carefully, per second, per capacity, per byte scanned. Three genuinely different ways to pay, and the right one depends entirely on how your workload behaves. So which pricing model actually fits you? Here is the rule of thumb. If your workload is steady, predictable and heavy capacity and provisioned models tend to be cheaper. You are renting a fixed engine and running it hard. But if your workload is spiky or exploratory, pay per use wins. That is Snowflake per second or BigQuery on demand. You only pay when you actually run. And what if you are mixed? Most real teams blend. Reserved capacity for the steady base, pay per use for the spikes. Here is the decision tree, and this is where it gets actionable. Start with one question. What is your cloud and what is your priority? If you are all in on AWS with a team that wants control, Redshift fits naturally. If you are on Google Cloud or you want zero cluster management for ad hoc work, BigQuery. And if you are multi-cloud, doing heavy data sharing, or you simply want ease plus elasticity, Snowflake, three branches, three clear answers, burn this tree into your memory. It is the fastest honest answer you can give. Let us apply that tree to a real scenario. Picture a small startup. Everything they run lives on AWS. Predictable nightly ETL plus a few BI dashboards. No surprises in the workload. The likely fit here is Redshift serverless for tight AWS integration and steady cost, or Snowflake on AWS if they want more ease. So what decides between them? One question. Do they value AWS native control, which points to Redshift, or hands-off elasticity, which points to Snowflake? Same context, two valid answers, one deciding factor. Now a very different shape. Picture a multi-cloud enterprise. Many business units, data shared across partners, workloads spread over both AWS and Azure. This is a different world. The strong fit here is Snowflake, multi-cloud reach plus best-in-class secure data sharing. And here is the deciding factor. For this company, cross-organization sharing and cloud neutrality outweigh single cloud cost tuning. When sharing data across boundaries is the core need, Snowflake sharing model is genuinely hard to beat. One more scenario, and this one swings the other way. Picture a Google centric shop, their stack lives on Google Cloud. They run occasional huge ad hoc scans, the kind that hit a giant table once in a while. And they have no team to babysit clusters. The strong fit here is BigQuery serverless. It scales invisibly and it plugs deep into Google. The deciding factor is simple: zero ops plus paper scan beats managing capacity when your use is spiky. For busty work, paying only for what you scan is exactly right. Let us cut this a different way by workload type. First, concurrent BI for many analysts at once. Here, Snowflake multi-cluster shines and BigQuery scales invisibly too. Second, tight AWS integrated ETL with predictable load. That is where Redshift is genuinely cost effective. Third, exploratory and bursty work where you query a huge table only occasionally. For that, BigQuery on demand or Snowflake with auto suspend. Notice each platform owns a real lane. Match the lane to your dominant workload and the choice gets obvious. Now, here is a factor people underweight, and it is huge. Your existing cloud commit and your data tools matter more than any benchmark. Let me say that again, because it is the practical truth. Your ecosystem usually decides this. If you are an AWS shop with deep Redshift skills, the switching cost may outweigh any marginal gain elsewhere. And if you live in a heavy Google Ads and analytics stack, BigQuery's native integration is a real advantage. The best warehouse on paper is not always the best warehouse for your team. Let us be fair and name where each one genuinely wins. Snowflake wins on ease, elasticity, multi-cloud reach, and best-in-class data sharing. Redshift wins on deep AWS integration, maturity, and cost control for steady workloads. BigQuery wins on serverless simplicity, massive ad hoc scans, and tight Google integration. Read those again. Every one of these is a real strength. None of these platforms is a toy. The question is never which is good. The question is which strengths match what you actually need. And to be equally honest, let me name the friction in each. Snowflake is a separate vendor and its cost needs active management. We cover exactly that in the cost video. Redshift gives you more tuning and ops knobs and classic node management if you are not on serverless. BigQuery's per bytes pricing can surprise you on a careless scan, and it is Google Cloud centric. None of these is a deal breaker, but you should walk in with eyes open. Every platform asks something of you. Know the tax before you sign up for it. Now, a trap I see smart teams fall into: picking a warehouse by marketing benchmarks. Here is the problem: vendor benchmarks are tuned to make that vendor win. Treat them like ads because that is what they are. The only benchmark that matters is your queries on your data. So before you commit, do this. Run a small proof of concept on your real workload. Load your actual data, run your actual queries, measure the actual cost. That single test tells you more than 100 vendor slides ever will. And let me ground you in the migration reality, because this is the real stake. Switching warehouses later is real work. SQL dialect differences, remodeling, retooling, and retraining your whole team. It is not a weekend project. So pick for the next few years, not for this quarter's price. Here is the hard truth: the cost of a wrong sticky choice dwarfs the monthly bill difference. A few $100 saved now is nothing against a year long migration later. Choose for the long road. Let me hand you the whole thing on one card. Keep this. AWS plus a need for control points to Redshift. Google serverless or ad hoc points to BigQuery. Multi-cloud data sharing or pure ease points to Snowflake. Then layer in pricing. Predictable load favors capacity pricing. Spiky load favors pay per use. And over all of it, two rules that never change. Always benchmark your own workload. And always weigh your ecosystem and your migration cost. That is the entire decision on one screen. So, a fair question: which one should you actually learn? Let me give you the career view. Snowflake and Databricks dominate cross cloud data engineering job posts right now. If you are AWS locked, Redshift skills travel well. And on Google, BigQuery is your answer. But here is the freeing part: learn one of them deeply first, because the core concepts transfer across all three: separation of storage and compute, data modeling, cost control. Master those ones, and you can move between any of these platforms. So let us bring it home. You now have the comparison matrix, the decision tree, and the honest trade-offs for all three warehouses. You can walk into any room and decide on fit, not hype. That is a real skill. If you are going Snowflake, the full masterclass architects it properly, and the link is below. And subscribe because the Databricks and Fabric comparisons are coming next in this season. I would genuinely love to know which one did you pick and why. Drop it in the comments, and I will see you in the next lesson.